In example 7, 8, 9, and 10, we are looking at the factorial. So this is not an exclamation mark in mathematics, it is a factorial. So when you read this, it's not 6, it's 6 factorial, which means you're doing 6 times 5 times 4 times 3 times 2 times 1. And so that would be 720. So 6 factorial equals 720 if you multiply all those numbers. So 5 factorial would be 5 times 4 times 3 times 2 times 1. And that is 120. What if you divide them? So what I recommend is multiplying or writing it all out. 7, 6, 5, 4, 3, 2, 1. That's all being multiplied. And then 6, 5, 4, 3, 2, 1 for the 6 on the bottom. And then these all cancel each other out, and so you just get 7. Here I've got 7 on top, so 7, 6, 5, 4, 3, 2, 1. And then on the bottom I've got 5, 4, 3, 2, 1, and another 2, 1. So if I cancel out my 5, 4, 3, 2, 1, since we have them on top and on bottom, I end up getting 7 times 6, which is 42, over 2 times 1, which is 2, and so I would end up getting 21. Then on the back, on number 11, we are looking at 7 combination 3. So this is a combination. We do this when we talk about probabilities, but it also helps us with binomial expansion theorem. So we've got 7 on top, 3 on the bottom, and to solve it, you use this equation here. So you would take your top number, which is the n, and you do that on top, so 7 factorial. And then you've got your bottom number, which in this case is the 3 or the k, so 3 factorial, and then n minus k factorial. So the difference between those, 7 minus 3, is 4, so 4 factorial. And if we do it all out, 7, 6, 5, 4, 3, 2, 1, over 3, 2, 1, and 4, 3, 2, 1. My 4, 3, 2, 1 is going to cancel, and I get 7 times 6 times 5 on top, which is going to be 210. And then I have 3 times 2 times 1, which is going to be 6 on the bottom. And so that is giving me 35. Now, a way to check your work, or a way to do it without this theorem, is to look at Pascal's triangle. So if it says 7 combination 3, you're looking at row 7, and you're going to go over to the third number. So row 7, sorry, okay, row 7, the 1 is counted as term 0, so that'll be, we've got term 1, 2, 3, so we're talking about the 35, which is what we just got. 6 combination 4, so that's going to be 6 factorial over 4 factorial, and then 6 minus 4 is 2 factorial. So if we write that out, 6, 5, 4, 3, 2, 1, 4, 3, 2, 1 times 2, 1, then the 4, 3, 2, 1s cancel, and we end up getting 30 over 2, which is 15. If I go and look at Pascal's triangle, row 6, fourth number, so row 6 would be here, and then we've got 1, 2, 3, 4. We ended up getting 15, which is what we got there. 8 combination 2, we've got 8 factorial over 2 factorial, and then we subtract them and get 6 factorial. So that'd be 8, 7, 6, 5, 4, 3, 2, 1, 6, 5, 4, 3, 2, 1, and 2, 1. The 6 through 1 cancel, and we end up getting 56 over 2, and so that is going to be 28. And then how can we use a combination of this to help us with binomial expansion? Well, say we don't want to expand the whole thing, but we only need part of it. So when we're looking at this, the n and the k that we were talking about earlier, this n and this k, the n is going to be your exponent, and the term is going to be your k. So this just wants the third term of this. It doesn't want us to expand out the whole thing. So what we're going to do is use this formula up here. This is how we're going to find it. Okay, so this says summation of the combination, and then we've got the first term, and we do n minus k, and then we have the second term with k. So I've got then 7 combination 3, and then I've got a to the n minus k. So in this case, a is actually a. And then we have n minus k, and I shouldn't have put a fraction symbol. That's just from habit. There's no fraction symbol there. 7 minus 3 is the n minus k. And then you've got your b, which in this case is a negative b, and to the k, which is 3. And so what we have here is 7 combination 3. Now you can either look up here, we already did it. 7 combination 3 is 35. So you can either do all the work or you can go to Pascal's triangle and find it. But you end up getting 35. And then that'd be a to the 4th. And then negative b cubed, which makes the whole thing negative, and then b cubed. So that is the third term. So let's find the fourth term of this binomial. And so I've got 6 combination 4. And then we've got the first term here is x, and you subtract those numbers. And then your second term is 4, and it is the bottom number. And so we've got 6 combination 4, which we did up here. It's 15. So you saw how we did it before. We get 15. And then we have 6 minus 4 is 2. And then we have 4 to the 4th, which is 256. And then we multiply that by 15, and we get 3,840x squared. Find the fourth term of this one. So I've got 4 combination 4. And my first term is 3x, and we then subtract those. My last term is negative 5y, and we have the bottom one. So 4 combination 4, if you want to look at that, we would do 4 factorial, and then on the bottom you have k factorial, and then you have 4 minus 4 factorial, which would be 0. And so that's a little weird that we get a 0 down there. So they treat it as if that 0 isn't really there, that you're just doing 4 divided by 4, which is 1. You end up getting 1 for this. The other way to look at it is go to row 4 and the 4th number. And so if we look at that in Pascal's triangle, we've got 1, 2, 3, 4. The 4th number is 1, if you want to do that instead. So I've got 1, and then I've got 3x to the 0, which means nothing. And then I've got 5 to the 4th, which is going to, well, negative 5 to the 4th, which is positive 625, y to the 4th, and so you get 625 y to the 4th.